Good morning, everyone. Chapter Radiation, Session 4. In our last session, we have discussed the statement of a Wein's distribution law, Wein's displacement law, and a Rayleigh-Jeans law. In today's session, shall we cover the topics brief account of Planck's hypothesis, then the derivation for a Planck's law of radiation. Planck's law of radiation is very important for your examination for 4 marks. ನಿಮಗೆ maximum derive the Planck's law of radiation ಅಂತ derivation ಕೇಳ್ತಾರೆ 4 marksಗೆ. ಸೊ ಕರೆಕ್ಟಾಗಿ ಅದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. First, we will see the Planck's hypothesis. Planck's hypothesis. In order to explain the distribution of energy in the spectrum of a black body, Max Planck in 1901 proposed the quantum theory. 1901 ನಲ್ಲಿ Max Planck proposed the quantum theory. According to this, that is the theory or the Planck's hypothesis, any radiation emitted or absorbed, any radiation is emitted or absorbed in discrete packet of energy is given by E is equal to nh nu. Once again, the statement for the Planck's hypothesis, according to the Planck, that is according to the quantum theory statement, any radiation is emitted or absorbed in discrete packets of energy is given by E is equal to nh nu, where n is a integer, n is an integer, that is the value 0, 1, 2, 3, so on. H is the Planck's constant, nu is the frequency of radiation. The packets of energy, ನಾವು ಹೇಳಿದ್ವಿ ಅಲ್ವಾ ಆಗಲೇ ಡಿಸ್ಕ್ರೀಟ್ ಪ್ಯಾಕೆಟ್ ಆಫ್ ಎನರ್ಜಿ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ಸ್ ಅ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಅಥವಾ ಅದು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಇರೋದಿಲ್ಲ, ಡಿಸ್ಕ್ರೀಟ್, ಇಂಡಿವಿಜುವಲ್ ಅವರ ಸಪ್ರೇಟ್ ಮೀನಿಂಗ್. ದ ಪ್ಯಾಕೆಟ್ ಆಫ್ ಎನರ್ಜಿ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ಕ್ವಾಂಟಾ ಆರ್ ಫೋಟಾನ್ಸ್. ನಾವು ಅದನ್ನ ಫೋಟಾನ್ಸ್ ಅಥವಾ ಕ್ವಾಂಟಾ ಅಂತ ಕರಿತೀವಿ. Thus, the exchange of energy between the radiation and matter does not take place continuously, but in discrete packets of energy, or it is quantized. Once again, coming to the statement, according to this, any radiation is emitted or absorbed in discrete packet of energy, and the equation is given by E is equal to nh nu, where n is an integer, h is a Planck's constant, nu is a frequency of radiation. This is about the Planck's hypothesis. Next, move on to the derivation for a Planck's law of radiation. Next, move on to the derivation for a Planck's law of radiation. According to the Planck, a black body radiation chamber contains infinite number of oscillators. Each oscillator is having its own natural frequency. ಏನಂತಂದರೆ ಆ ಬ್ಲ್ಯಾಕ್ ಬಾಡಿ ಚೇಂಬರಲ್ಲಿ, ಆ ಬ್ಲ್ಯಾಕ್ ಬಾಡಿ ರೇಡಿಯೇಷನ್ ಚೇಂಬರಲ್ಲಿ ನಿಮಗೆ ಇನ್ಫೈನೈಟ್ ನಂಬರ್ ಆಫ್ ಆಸಿಲೇಟರ್ಸ್ ಇರುತ್ತೆ. ಆ ಈಚ್ ಆಸಿಲೇಟರ್ಸ್ ಹ್ಯಾಸ್ ಇಸ್ ಓನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, ದಟ್ ಇಸ್ ಹೆಚ್ ನ್ಯೂ. ಅದಕ್ಕೆ ಪ್ರತಿ ಒಂದು ಆಸಿಲೇಟರ್ಗೂ ಅದರದೇ ಆದಂತಹ ನ್ಯಾಚುರಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುತ್ತೆ. ಮೂವ್ ಆನ್ ಟು ದ ಡಿರೈವೇಷನ್. ಲೆಟ್ಸ್ ಕನ್ಸಿಡರ್ ಅ ಕ್ಯೂಬ್ ಆಫ್ ಸೈಡ್ ಎ, ಸ್ಮಾಲ್ ಎ ಇದೆಯಲ್ಲ ಅದರ ಸೈಡ್ನ ನಾವು ಎ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ, and containing n number of oscillators at a temperature T. Small n is the n number of oscillators, then T is the temperature. If n is the total number of oscillators, now infinite number of oscillators anta helidvalva, total number of oscillators, it is represented by a capital N. Let n not have zero energy, n1 have energy h nu, n2 have energy 2h nu, and so on. Let n not have a zero energy and n1 have energy h nu, n2 have the energy 2h nu, n3 have the energy 3h nu, and so on. Now the total number of oscillators is given by n is equal to n0 plus n1 plus n2 plus n3 plus so on. Call it as equation number 1. n is equal to n0 plus n1 plus n2 plus n3 plus so on. Call it as equation number 1. Then the total energy of these oscillators, is given as E is equal to N0 into 0 plus N1 into h nu plus N2 into 2h nu plus N3 into 3h nu plus so on. Then we are just taking where E is equal to h nu. Then the above equation becomes E is equal to 0 plus N1 into E plus N2 into 2E plus N3 into 3E plus so on. Then the standard solution for the arithmetic mean is given as E is equal to N1 plus 2N2 plus 3N3 plus so on into E. Call it as equation number 2. Then the total energy of these oscillators is given as E is equal to N1 plus 2N2 plus 3N3 plus so on into E. Call it as equation number 2. Now ಏನು ಮಾಡಿದೀವಿ E ನ ಕಾಮನ್ ತೆಗೆದಿದ್ದೀವಿ where E is equal to h nu. E is equal to h nu. Then according to the Boltzmann distribution law, the probability that a particular oscillator will have an energy nh nu. The probability that a particular oscillator will have means ಪ್ರತಿ ಒಂದು ಆಸಿಲೇಟರ್ಗೂ ಅದರದೇ ಆದಂತಹ ಎನರ್ಜಿ ಯಾವುದು nh nu. The standard expression for that is n is equal to n0 into e to the power minus ne by kt. Here small n is an integer where n is an integer, k is the Boltzmann constant and T is the temperature. ಏನು ಹೇಳುತ್ತೆ equation according to the Boltzmann distribution law? n is equal to n0 into e to the power minus ne by kt, where n is an integer and k is a Boltzmann constant. T is the temperature. Now put e to the power minus e by kt, which is equal to y. That is the exponential e to the power minus e by kt equal to y. ನೀವು ಎಬೋ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನು ಹೇಳ್ತೀರಿ ಮೈನಸ್ ಎನ್ ಇ ಬೈ ಕೆ ಟಿ ಅಂತ ಹೇಳ್ತೀರಿ ವೇರ್ ಎನ್ ಇಸ್ ಆನ್ ಇಂಟಿಜರ್. ಸೊ 0 1 2 3 ವ್ಯಾಲ್ಯೂಸ್ನ ಹಾಕ್ತೀವಿ ನಾವು ಅಲ್ಲಿಗೆ. ಹಂಗಾಗಿ ಪುಟ್ ಇ ಟು ದ ಪವರ್ minus e by kt which is equal to y. The above expression will reduce us to n is equal to n0 into y, where y is equal to e to the power minus e by kt. Now substituting the equation 3 in the equation 1, here equation 3 is n is equal to n0 into y, and the equation 1 is n is equal to n0 plus n1 plus n2 plus n3 plus so on. See here, that is the equation 1. Substituting the equation 3 in equation 1, then we get n is equal to n0 plus n0 y plus n0 y square plus n0 y cube plus so on. Then n is equal to, taking common outside n0, n is equal to n0 into 1 plus y square plus y cube plus so on. Then the solution for the standard solution for the arithmetic mean is given as n is equal to n0 divided by 1 minus y. n is equal to n0 divided by 1 minus y. Call it as equation number 4. Similarly, ನಾವು ಈಗ ಮೇಲ್ಗಡೆ ಹೇಳಿದ್ದು ಯಾವುದಕ್ಕೆ total number of oscillators. Now similarly total energy, the total energy in the equation 2 becomes for the total energy equation 2 ಏನು ಹೇಳುತ್ತೆ E is equal to n1 plus 2n2 plus 3n3 plus on into E. Call it as equation number 2. ಅಲ್ಲಿಗೆ ನಾವು ಈ y ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ಈಕ್ವೇಷನ್ ಏನಾಗುತ್ತೆ ಅಂದರೆ E is equal to n0 y plus 2n0 y square plus 3n0 y cube plus so on into E. Then taking n0 y and E common there, then it becomes n is equal to n0 y E into 1 plus 2y2 plus 3y square plus 4y cube plus so on. Then the after simplifying the above equation, it becomes E is equal to n naught y into E that divided by 1 minus y whole square. Call it as equation number 5. Equation 5 is E is equal to n naught into y into E that divided by 1 minus y whole square. Equation 4 is n is equal to n naught divided by 1 minus y. Equation 5 is E is equal to n naught into y into E by 1 minus y whole square. Now, the average energy per oscillator is given by average energy, that is comparing the equation 4 and 5, that is the average energy per oscillator is given by E by n is equal to E by n, nothing but that is, see here, E divided by n. E divided by n ಮಾಡಿದಾಗ ನಿಮಗೆ ಏನಾಗುತ್ತೆ ವ್ಯಾಲ್ಯೂ E by n is equal to n naught into y into E into 1 minus y divided by n naught into 1 minus y whole square. E by n is therefore E by n is equal to there n naught get cancelled, then 1 minus y square 1 minus y whole square, that is in the denominator, and in the numerator 1 minus y get cancelled, then the remaining term is E divided by n is equal to E divided by n is equal to y into E that divided by 1 minus y. The average energy per oscillator is given by E by n is equal to y into E that divided by 1 minus y. In the above expression, substitute the value of y. Then we get, in the above, substitute the value of y in the above equation where y is equal to e to the power minus e by kt. See here, put anta bardidivi alva navu, y is equal to e to the power minus e by kt. ಆ ವ್ಯಾಲ್ಯೂನ e divided by n ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇದೆಯಲ್ಲ, ಸೆಕೆಂಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್, ಅಲ್ಲಿಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. Then E by n is equal to e to the power minus e by kt into e that divided by 1 minus e to the power minus e by kt. Therefore, E, after simplifying, E divided by n is equal to e divided by e to the power e by kt minus 1. Call it as equation number 6. Equation 6 is E divided by n is equal to E by e to the power e by kt minus 1. Call it as equation number 6. Therefore, the total energy in the cube, now cube na consider ಮಾಡ್ಕೊಂಡ್ವಿ ಅಲ್ವಾ, let's consider a cube of a side a ಅಂತ ಹೇಳಿದ್ವಿ ಅಲ್ವಾ ಫಸ್ಟ್ ಅಲ್ಲೇ, ಅದು. Therefore, the total energy in the cube in the given frequency ranges between nu to nu plus d nu is given by ಓವರಾಲ್ ಅದರಲ್ಲಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ರೇಂಜಲ್ಲಿ ನಾವು ತೊಗೊಂಡಿರುವಂಥದ್ದು 8 pi ನ್ಯೂ ಸ್ಕ್ವೇರ್ ಬೈ ಸಿ ಕ್ಯೂಬ್ ಇಂಟು ಎ ಕ್ಯೂಬ್ ಇಂಟು ಇ ಡಿವೈಡೆಡ್ ಬೈ ಇ ಟು ದ ಪವರ್ ಇ ಬೈ ಕೆ ಟಿ ಮೈನಸ್ 1. ವಿ ಆರ್ ಜಸ್ಟ್ ಟೇಕಿಂಗ್ ದೇರ್ 8 pi ನ್ಯೂ ಸ್ಕ್ವೇರ್ ಬೈ ಸಿ ಕ್ಯೂಬ್ ಇಂಟು ಎ ಕ್ಯೂಬ್ ಇಂಟು ಇ ಡಿವೈಡೆಡ್ ಬೈ ಇ ಟು ದ ಪವರ್ ಇ ಬೈ ಕೆ ಟಿ ಮೈನಸ್ 1. Now the energy density is given by E nu d nu is equal to 8 pi nu square by c cube into a cube into h nu d nu divided by e to the power h nu by kt minus 1 whole divided by a cube. See there, ನಾವು ಈ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಕಾಣಿಸ್ತಿದೆ ಅಲ್ವಾ ನಿಮಗೆ, ಮೇಲ್ಗಡೆ ಏನಂತ ಬರೀತೀವಿ, therefore the total energy in the cube in the given frequency range, that is frequency ranges between nu to nu plus d nu ಅಲ್ಲಿ ಬರೆದಾಗ ಆ ಇಕ್ವೇಷನ್ ಅಲ್ಲಿ ನಾವು ಈ ಬರ್ದಿದ್ದೀವಿ, e divided by e to the power e by kt minus 1. Now the energy density define ಮಾಡುವಾಗ E is equal to h nu, ನಾವು ಎಕ್ಸ್ಪ್ರೆಷನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ, ವೇರ್ ಇ ಈಸ್ ಈಕ್ವಲ್ ಟು ಹೆಚ್ ನ್ಯೂ, ಆ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀವಿ, ಕಾಣಿಸ್ತಿದ್ಯಾ. ಇ ನ್ಯೂ ಡಿ ನ್ಯೂ, ದ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ ಇ ನ್ಯೂ ಡಿ ನ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು 8 pi ನ್ಯೂ ಸ್ಕ್ವೇರ್ ಬೈ ಸಿ ಕ್ಯೂಬ್ ಇಂಟು ಎ ಕ್ಯೂಬ್ ಇಂಟು h nu d nu divided by e to the power h nu by kt minus 1 whole divided by a cube. Then a cube get cancelled. Above expression reduces to E nu d nu is equal to 8 pi nu square by c cube into h nu d nu divided by e to the power h nu by kt minus 1. Therefore, it can be written as ಅಲ್ಲಿ ನಿಮಗೆ ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇದೆ 8 pi nu square h nu ಇದೆ ಅಲ್ವಾ, just multiplying that one 8 pi h nu cube ಆಗುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ equation 7 ಅಲ್ಲಿ. See there. Therefore, h nu d nu is equal to 8 pi h nu cube by c cube into d nu divided by e to the power h nu by kt minus 1. Call it as equation number 7. Equation number 7 represents the expression for a Planck's law of radiation in terms of frequency. That is the expression is E nu d nu is equal to 8 pi h nu cube by c cube into d nu divided by e to the power h nu by kt minus 1. This is the Planck's radiation formula. This formula completely explains the distribution of energy in the black body spectrum. Equation 7. This is the expression for the Planck's law of radiation in the frequency. Then move on to the in terms of wavelength. That is the expression for Planck's law of radiation in terms of wavelength using mu is equal to c by lambda. Using mu is equal to c by lambda and mod d nu is equal to mod of minus c by lambda square into d lambda, which is equal to c divided by lambda square into d lambda. Here model ಇದೆ ಅಲ್ವಾ ನಿಮ್ಮದು ನೆಗೆಟಿವ್ ಸೈನ್, ಇಟ್ ಕ್ಯಾನ್ ಬಿ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಆಸ್ ಅ ಪಾಸಿಟಿವ್ ದೇರ್. ಮಾಡಲ್ ನಾವು ನೆಗೆಟಿವ್ ಸೈನ್ ಇದ್ದರೂ ಅದನ್ನ ಪಾಸಿಟಿವ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋತೀವಲ್ವಾ. ಸೊ ದ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಸ್ಕ್ವೇರ್ ಇಂಟು ಡಿ ಲ್ಯಾಂಬ್ಡಾ. Substitute this value in the equation 7, then it becomes E lambda d lambda is equal to 8 pi h c, that divided by lambda to the power minus lambda to the power 5 into d lambda divided by e to the power h c by kt lambda kt minus 1. Call it as equation number 8. See there, in the equation 7 ನಾವು ನ್ಯೂ ತೊಗೊಂಡಿದ್ದೀವಿ ಅಲ್ವಾ, ನ್ಯೂ ಅಲ್ಲಿ ನಾವು ವ್ಯಾಲ್ಯೂನ ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಹಾಕ್ತಾ ಇದ್ದೀವಿ. ಡಿ ನ್ಯೂಗೆ ಮಾಡ್ ಡಿ ನ್ಯೂ ಅದನ್ನು ತಗೊಂಡಾಗ ನೀವು ಏನು ಹಾಕೋತಾ ಇದ್ದೀರಿ, ಸಿ ಡಿವೈಡ್ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಸ್ಕ್ವೇರ್ ಇಂಟು ಡಿ ಲ್ಯಾಂಬ್ಡಾ ತೊಗೊಂಡಿದ್ದೀರಿ. ದೆನ್ ದ ಅಬೌವ್ equation becomes in terms of the wavelength E lambda d lambda is equal to 8 pi h c by lambda to the power 5 into d lambda divided by e to the power h c by lambda kt minus 1. Call it as equation number 8. Equation 7 represents the Planck's law of radiation in terms of frequency. Equation 8 represents the Planck's law of radiation in terms of wavelength. This is about the derivation for a Planck's law of radiation. ನಿಮಗೆ ಇದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವೆಶನ್, ನಿಮಗೆ 4 ಮಾರ್ಕ್ಸ್ಗೆ. ಸೊ ಕರೆಕ್ಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ ಡಿರೈವೇಷನ್ನ ಆ್ಯಂಡ್ ಕಲ್ತ್ಕೊಳ್ಳಿ. ಇನ್ ಅವರ್ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ದ ಇಕ್ವೇಷನ್ 7 ಇದೆ ಅಲ್ವಾ, ಆ ಇಕ್ವೇಷನ್ 7 ಇಟ್ಕೊಂಡೆ ನಾವು ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಡಕ್ಟ್ ದಟ್ ಇಸ್ ಡಿಡಕ್ಷನ್ ಆಫ್ Wein's distribution law, Wein's displacement law, Rayleigh-Jeans law and Stephens-Boltzmann law in our next session. Okay, thank you.